And we're alive. Hello everyone, welcome to today's project. This one is just going to be something a little bit simple. Simpler than my attempted like groundbreaking math stuff with geometry nodes. This one is just going to be lightning, which is, not the most complex effect, not groundbreaking, but I want to put a little twist on it where it's lightning traveling over the character's body. In this case, I was inspired by Avengers Infinity War and Endgame, I guess, where the lightning would come from the gauntlet and then travel around and, I guess, through the character. So I want to try that. I think it won't be too incredibly difficult because I have a plan. So one plan is to make the particles that follow the object and just go vroom around the entire thing. And then once those particles do their thing, then I will trace those particles and then add in the quote-unquote lightning. So this should be fairly simple in terms of geometry nodes simulations. So let's get started on this. So first of all, we just need to add in, is the music too loud? Let me reduce that by a little bit. There we go. We need to add in our particles. So I want to keep spawning in particles. Actually, let's start off with just a few points. And then we can add in new ones later, once we get the initial effect going. So in this case, I'm just going to put in, let's do 100 just to test. And have a random value for their start locations. So let me do this, and we can place them anywhere. So let me put them in a 1x1 cube. That seems good enough. I just want to test the attachment to the surface and it moving along the surface, which hopefully will not be difficult. I don't think it will be. So in this case, we need to get the body part in here and get the geometry proximity. And let's see, grid snapping, I need that on. So in this case, I'm going to use a set position node. The position will be just that. So here we have the particles stuck to the surface, which is good. That's what we want. But then I'm going to make it so that these particles, the source position moves, which will kind of offset where it's looking to attach to. So in this case, it'll be a, let's see, a random value I'll add to this. This is like if I had a set position beforehand. And actually, it may be better if I have them separated. That may make this a little easier to understand. So I'll do that. So I'm going to offset the particle by a little bit. In this case, I'm going to scale this down by a bit. It'll be 1 and -1 again, except in this case, it'll be like 0.01. So offset, and then it will attach. So we can see here that it is actually working. That's pretty good. But it seems that they kind of get a little bit stuck, which I can change that in a few ways, but I want to see what happens if we put in the scene time frame node. What happens then? Because I want the really, like, scattered movement. I want to not use the velocity attributes that I usually use, but I think in this case we may need to do that again. It's a little unfortunate, but I think we'll have to do it. So to do that, I can store the offset. Yeah, that may be necessary. Like here we have the particles moving, but I want them to have a more consistent movement, instead of just being as scattered as that. Yeah, so let's store the velocity and then mix between the old velocity and then the new velocity, which is right here. So let me try this. Vector, I need to put that in here. So I'm going to mix between the old and the new velocity. So that will keep trying to go in its path dependent on that mix node. Then we just apply the velocity here. So let's give that a go. How does that feel? That is giving us a different vibe. Let's see. That is... Nope, that is not doing quite what I want. What if I were to add them together? This means that they will speed up over time. Uh-oh. It just crashed. How did it crash? Autosave? Okay, we have an autosave. Okay, I deleted that. Let's attach this. So that gives us a different effect. They have a lot of speed, but not... So they do that. I'm kind of okay with that, but... Let's see. I think I can stick with this for now. I mean, the particles, they're moving around, but they do have a more consistent direction. So let me put this into frames, and then I'll get started on the second part, which will just be a geometry node. So let me go and put these into frames. Just like that. Let's put this into there. So that just... Like, the velocity still isn't entirely accurate, because it doesn't recalculate after the movement, which I could do by just comparing the old position to the new position and then say, hey, that's your actual new velocity. Go have fun with that. So that's that, and I think I'll keep this as one simulation, but then for the other, and also I want to disable the cache on this, just so that it'll re-update whenever I change anything, which is a bit better in most situations. So now let's make another simulation zone. In this case, I want to bring the particles into here so that I can go and trace them. So let's do geometry, join geometry. What are you going to do with the particles? I want to make lightning. I was watching a little bit of Avengers Endgame again, as I do, not super often. I want to make the effect where the lightning from the Infinity Gauntlet travels over the character's body, as if the power is coursing through their veins, because I think it'll look cool. So I want to instance on points, and since we do... Oh wait, I will need to recalculate the velocity. Let's make this a curve line, because I want to trace that. Okay, so I will need to make the velocity accurate. Let me just view this currently. So here we have the line spawning in there. But if we have an align Euler to vector node, we basically turn that velocity into a rotation we can use, which looks like that. But then we get the length, and as per usual, we plug that into there. So here we can see the problem I was mentioning. The velocity is not accurate. So we need to recalculate the velocity after the snap or not the snap. Let's put that into a frame. We need to... Actually, let me think about this. So I could recalculate the velocity after the fact, which is kind of like a band-aid for everything I do. So if I do anything in here, I could just recalculate it at the end and then boom, it's good. Or I can just implement the offset here into the velocity there. I think I'll go with the one with less nodes, not more. So here, let's take that out. As much as it pains me to complicate this even further, it'll be less nodes. So I'm going to do what I did before, add this to the position for the source position here. And then to change the geometry proximity into a velocity, we now basically undo what we just did. So we subtract that position by the current position, and now we have the velocity. So now we should see, it should be much more accurate, but I think I need to set that to negative. And I need to set that to Z. There we go. Yep, that's working. So we can see that the particles are going over the body, which actually looks a little bit gross at the moment. So let's turn this into lightning fast. So I'll leave that in a frame like that. This man is a wizard. No, this man will be a wizard. We don't need the simulation zone right now because I don't... Well, we'll see if I can make the trails. Looks like bugs right now. That is what I am trying to avoid. So I'm going to realize the instances, and this would happen after the simulation if I implement trails, but I'm still not sure about that. We realize the instances, and then we resample the curves, and then we want to add some noise to those curves. So I'll just do a set position node. Now I'll offset it by a noise texture. So I'll just subtract by 0.5 and then scale. So I'll delete the simulation zone. I may add that back in later, but we'll see. So here we can see that happens, which we don't quite want in that regard. But here we can see there's the lightning. There's the lightning. There we go. Much better. So I just want to make it so that these, the endpoints are stuck to the geometry, which is easy enough to do. We just go and use the spline parameter, and then use a color ramp. A float curve would be better. Float curve. Because I can change the kind of arc that goes along and make it look better. So in this case, it'll be up 100% and this down. So here we can see that happening. Which now I'm realizing... Here, it needs more resolution. More roughness. So here we can see it is far too powerful. So here it looks like this. So I may need the trails to make it so that these will be longer and account for, being around for longer. But let's set up the meshing first, and then we can deal with everything else afterwards. So I'll just collapse this, put this into there. Collapse this, put this into a frame. Remember to use frames, everyone. Like, even though I'm not labeling everything here, which I should. Instance, trail, more points, or, no, resample. Resample, this will be rotation / scale. There we go, and that's just noise, that's self-explanatory. So then we need to mesh the curve right there. No, mesh curve. To mesh, curve to mesh. There we go. Then I'm going to make this a circle, a curved circle. There we go. Let's set that to like 3. Let's take a look. Way too big. Let's go and reduce that even further. And then we need to set a material. So set material, let's plug that into there. Material 01, set this to emission. Change the viewport display to blue. And change this to a glowing blue. So here, we just need a... Yeah, it looks like I'll have to implement those trails. So, a few things that may need to be done. One is those trails, so that there can be longer and shorter versions of this. But that requires basically simulations, and to be honest, I really don't want to do that. 0.5. I'll try. I'll give it a go, and we'll see how that goes. So that meshes it. That's for the noise. So in between here and then the realization and all that, I just need to make it so that we can preserve a few of these over time. So we do the simulation zone, geometry, join geometry right here, plug that into there, and then plug the output into here. So this will preserve every single one. And that slows down dramatically. Where's simulation nodes? Take out the cache. Whoa, well, yeah, why is that being so non-performance? Timings? What the heck is happening? Is it just that bad? No way. Here, let me make it so that... Let's make this 2 instance. Then plug it into here and we'll see what happens then. Looks like that bug still persists with the... Oh, I'm just going to lag out horrendously. Because all of this... How much does this take? 2.1 milliseconds for that, so why is it lagging out? Is it just the amount of instances on screen? Well, then I will not realize the instances. Let's see what happens then. Nope. I thought they fixed that. Because here, all this is taking 17 milliseconds, which isn't nothing. Okay, we're not going to deal with that. We'll just change the effect that we currently have. So I just need to speed up these. Yeah, no, I think I may need the trails. What are your PC specs? I'm running a whatever generation i5 processor, Intel, and a RTX 3060. So that should not have been lagging. Ever since simulation nodes got merged, all of a sudden whenever I do that kind of trail effect, it starts lagging out. Which I thought that got fixed, if I'm being honest, but I'll have to look into it and possibly make a bug report. Because I've done that with much denser meshes, and it ran perfectly. So it must be trying to store all that data somewhere and having a difficult time. So anyway, not to bog everything down, but let's go, yeah, let's try to implement the trail, but be smart about it this time. So geometry, join geometry. I'm going to implement the age deletion. So I'm going to store named attribute, then I'll delete the instances, make sure these are both set to instance, so that I can only have, say, they'll only be alive for like 4 frames. Age, that's the new parameter. Add, and then age. This will be added 1 every single frame. And then if the age gets too big, greater than, I'll do greater than 4. They will delete, and then we realize those instances. Huh, well that's not lagging. So here we get kind of a more stylized lightning effect. Interesting. So there's our trails. So let me put these into frames. I'll label this trail length. Nice, I got a laptop a week ago today with a 4070 and an i7. A laptop exists with a 4070. That is something I did not know. So here, oh, actually, I think 2 frames are fine. Like it does kind of disappear kind of abruptly. Actually, I think the particles are just moving a bit too slowly. So let's go back into the, well, this will be sim particles. Let's go move that into a new collection. And then this will be trails. And I'll put this in green so that I can view that very easily. So the actual math behind, you know, the particles moving is fairly simple. I'm very happy about that. Let's speed it up. Now, a couple things that I may want to change. Let's see. I need to think about this one. So I think I may want to store... I got the velocity. And then I offset... I may need to get the object normal. so that I can... So let's use sample nearest surface. Change that to vector. Let's make this the normal. So I'm going to store the normal so that maybe I can offset the lightning, like the middle part off the body a little bit. So that's that part. And now that we have that, let's go into the trails, which I guess, yes, that should be in the simulation collection. So I'm just going to add in the normal into here. So store named attribute, where's normal? Normal. And then we scale that, plug it in. Then we should see... Ah. Well, we can see that it works, just a little too well. So that makes it so that that happens. So we can have that going. But we're currently seeing just a little issue with this. It's that because I set it up so... Actually, wait a second. It's way too harsh. So maybe something like that. I'll set that to 0.1, just so that the arcs are a little better. So here we can see that when it goes along, like when there's 2, it goes dunta. Well, maybe I want it so that it's all combined. I mean, this isn't bad, but... It is feeling more like bugs than what I was hoping for. Let's go back into the sim and let's edit that until it feels right. So here... I think because they speed up and slow down, it feels more bug-like. Well, Let's see, let's try to get the vibe right, because the vibe is off. So here, it's too fast. But the more noisy lightning is good. I also want to set the radius. Set curve radius by the parameter as well. So that kind of fades off at the ends. Set this to like 4. So here we can see that happening. Maybe I make the noise texture randomly animated for every single frame. So let's have this be a random value. This no tree's getting big. That's just what happens. You blink, and then you're like, oh, wait, I need all these features. So I'm gonna make it so that's randomized. Per spline. Evaluate on domain, spline. There we go. So that... I was a little worried that would happen. Now it's looking like... not like lightning. So if I just have that, it's way too fast. If I have this, it looks way too segmented. We need to get the vibe right. So, it looks like I'll have to do a few things. One is that I may need to merge the ends. Like, merge the trails together, which unfortunately is not super easy to do. But I need to switch the curve to a mesh, merge by distance, then mesh to curve. So now it looks like that. Let me up the normal offset. Excuse me, you should be... oh wait, I need to realize the instances before I do that. So now it should work. There we go. So now we can see that when it goes over multiple frames, and maybe I should smoothen it. Here, okay. So, let's fix a few of the problems. We're bug fixing here. Looks like bugs. Let me turn up the frame rate also. It looks like bugs. I dislike that. Quite a bit. It just feels way too hyper. Like it's either bugs or way too hyper. We should also plug in the trail length to control how offset this all is. So if I get the spline length, I knew what I wanted that time. Then multiply this, multiply, plug that into there, plug this into up there. Then we should see that happening. Maybe I should put in like a better control, a multiplier. So that just means when the spline gets longer, it'll go up higher, more proportional, and everything like that. So let's go and make it so that when it, well, why does it look like bugs? I highly dislike that. Okay, so back to SimParticles. Make it faster. They're having quite the party. I guess that could be lightning, but again, not the lightning that I wish for. So another little problem. I need to make it so that, yeah, we're seeing the problems with this. Looks like I need to, okay, let's regroup on this. We are already past the point of, oh, let's make this easy. We're at the point of, oh, let's just make this work. How we see it in our minds. See, there's that part. So, after the resample, I'm going to smoothen or blur the position. So, blur. But I need to make sure that doesn't happen on the ends. So here, if we do this, we can see that that happens. Which I think will be a net positive for all this. I'll set it to like 20 so that it's easier. I think that'll be enough geometry for all of it to happen. But I need to make it so that it's not on the ends, so I use some Boolean math to say not. So that it will not work on the ends. Wait a second. Right, it's not working on the ends, correct? Why is the normal messed up? Okay, let's take a look at these trails again, because something is incorrect. You know, I'm going to sample. Okay, instead of doing the sampling here for the normal, I'm just going to do it in the trail, so that we have it accurate for the entire trail. And it looks like I will have to evaluate this on the face domain, on the point domain to basically smoothen out the normals, because that does not happen automatically. That gives us a more smoothened out effect. Then I just need to reduce that. So now, if I hide this, I still don't know why it's so... This doesn't feel right. Like, why does that happen? Oh, wait. Oh, that worked, though. That fixed it. Okay, I need to keep that in mind. I probably should sample the normal... Wait, what the heck is... Okay, let's regroup this. So I'll sample the normal, or store it, before the resolution goes up, so that there won't be any, like, weird snapping. Welcome to coding, folks. This is visual coding, though. Where, you know, things are... Yeah, to get what you want, you need to really hammer into the computer's head. So we're getting closer. We now have the lightning doing all of that. Very nice, very good. And then, Do I add back in the noise? Yeah, let's do it. It was needed, but I wasn't sure if I should do it before or after everything else. So there we go. It's still way too fast. Let's go back to the particles. Slow them down to half speed. Again, we're trying to stay away from the bugs. Which we are doing an amazing job at. Well, that's interesting. I also may have to set the particle ID early. That ID, I'll have this be just a random value. It's really high. The Blender devs do that as well. I don't know why it's completely freaking out like that. Let's... Okay. The nodes are getting out of hand, so let me put them back in my hand. Sorry for being so scatterbrained with this one, folks. I try to do these things in the simplest way possible, but quite often, it needs to be complex. As we can clearly see here. Put everything into groups just to keep things nice and organized. So just for meshing the lightning, we can see that this has spiraled way out of control. So... Oh, that's because that's every single frame. So now if I do that... It still freaks out. Let me turn off the noise and see. So it does that weird wobble, which I assume is a side effect of the smoothing. That to 10. Here, let's see. What does that look like? So that's more consistent. But still odd, I will say. So let me go and turn up the count. So that we see... So that's because of the normal freaking out. What if I were to set spline type? Let's take a look at this. Set this to Bezier. Or NURBS? Let's take a look at what happens after that. Well, that is a different effect. Kind of cool. And then I need to resample in order to... Why? Sorry about this, folks. Position. Okay, so it's still consistent now. At what point does it become terribly inconsistent? Let's actually turn off the normal. Why does that weird... So I still think too slow. We need... It could be only on for 5 frames. Okay, I think we're getting closer. This will make it so that I'll have to speed up every single time. Randomizing it per frame. Gives it the more frantic nature, but I'm not sure if I want that. Let's keep moving this up. Let's resample it even further. We don't need you anymore, so let's chop out all the unnecessary parts. Plug you into here. So we're going down in the node count, which is very nice. Very happy about that. Five. Don't think the trails are too long. I get going like that. That gives more of a lightning feel. Then we can use the normal. Why does that make it feel worse? Like just slightly above that's all right. There we go. That's feeling a bit more like lightning. So I'm still... I think I know what may be a problem. Here, let's try this, where it's... No, that just looks bad. $37 minutes, and we're getting a result, but I'm still not happy with it. So let me go back to the particles. Let's do these. Let's spawn in new particles and see how this affects everything. So in this case, I'll have one particle spawn in every single frame, and for the position, I'll make an empty so that I can decide where these particles spawn in at. It'll be right there. Let's go back to the particles, bring in the empty, so that the particles will start off in there. There we go. Let me put that into a frame, join it in there, and then we'll see that they all follow the same path. Oh, that actually looks pretty cool. And I'm also realizing that they will literally never die, which may be a bad thing. So I'll have to put in an age parameter for them as well. Okay, so let's put in the random value for the random position offset. Vector, let's make this so that it changes for every single frame, which I may have to do for you as well. So, need to have that. Set that to 1, -1. Scale it, collapse this just so that it doesn't take up too much space. So now we should see. Yep. Let's make this a lot smaller. Move this up to here. I'll have to plug this into there. And there. Because I need to see... Actually, we don't need you. Let's change this to a float. Because I want to store a random color for every single one of these. Because we're trying to make the Infinity Gauntlet lightning. So it needs to be multicolored. So let's give this a go. Plug this into here. That's all that. I'll go and do this. Wow. One singular particle. Very nice. So here the particles will keep building up, which is why I need to implement the age. Which actually, I'm going to change the name here. So that's HI, so that these do not possibly conflict. But I can just go and copy this. and bring it into here. Unfortunately, making it bigger, but that's what we have to do. So I just need to change this to point and point. Just make it age so that these will last for, let's say, a second. So 30 frames. Go and delete. See how that goes. Still feels hyperactive. Let me go and put this into the big frame again. That made it just feel better. Can delete that. Okay, now with all of that in place, I think I could go into the shader for these ones. And let's get access to the attribute, which I labeled random. Let's take a look. Does it show? Yes, it does. Good. So now we can make this all the colors to make the Infinity Gauntlet. So, to saturation value, let's label this to far. There we go. I mean, it kind of works. It mostly works. Let's set it to 400 brightness. It's so... Yeah, the vibe is still wrong with it. It's trying to stay in its current velocity still. It's trying. Let's extend the trail to 10 again. Maybe making that based on the length was a bad idea. I mean, the lightning is consistent. Still a bit unsure about it. I also want to try the different shaders. I would like for it to be larger at the base of it, but then really small. Zero 5. Actually, no, this shouldn't be arc lightning, because... Yeah, no, it should not be... No, this is an arc lightning. Like, the only reason I have kind of an arc going is so that it doesn't clip into the mesh. This is supposed to be on top. It's just supposed to be almost a texture on top, but just with a little bit of that happening. And then with this, I'll just animate the noise going up. So I'll use this and then multiply this by seconds, except I want this on a vector math node, so that I can decide just how fast the noise moves. The problem is... Oh no, that's actually working okay. But I think I'll change this from a 3D noise texture to 1 dimension of noise. I'll get the random attribute. Random. And that, well, actually, do I want it in the world space? We'll see. Let's get the spline. line parameter. I want to get the length input, plug it in there. That's what I was worried about. Well, if I were to get the age parameter, plug it into there, then just set that to a lot less. A lot less. Maybe position was the right way to go. Okay, let's do that. Ooh, that's kind of cool. That was like at 6. I just don't like how you can clearly see the upwards movement of the noise pattern. A little bit of a shame. Like, I could make it so that it's a random direction for every single one, so that you can't pin it down. Still a bit too frantic, so let me slow it down. Actually, that's interesting. So, also, these are way too bright, as we can see here. So I think 0.6 is the right way to go. Let's try resampling this to like 200 just to see what that looks like. That's 200? Really? That actually looks a lot better. We're getting there. It's just taking time. I'm surprised it takes that much. Like, now it's starting to slow down, which is to be expected. But for the look we get, that's actually not too bad. So I'm still considering putting in the normal a bit more. Still not quite right. Let's bring the arc back up a lot so that I can just... and bring this back down to like 1. Nope, 2. It's starting to feel right. Okay, maybe I need to change the shader now because it's starting to blind me. Let's set this to like 250. Nope, 100. So we can see that. And the part where it's condensed, it's way, way, way too bright. So maybe I'll just make it less condensed. Maybe let's try moving this to other places. So here we have it there. Here we have it here. Even though that looks the best. So I think also the particles are lasting for too long. So let me go into the particles and reduce their lifespan to 15. That feels accurate. Yeah. The one issue is that since we're not in cycles, not getting like all the, you know, the bounced lighting and all that. But we need the bloom, the Eevee bloom. I could do that in cycles, but it's fine. It's just fine. I'm okay with it in its current state. Though I could set the character to be a bit shinier, but I'm not sure if it'll appear. What if I set the specular? It's oh wow. Okay, let's delete the. This is a cheat, but I want to see if it actually does work. Set the specular up really high, that it looks like actual bounced lighting. Like, it is kind of working. I think that's just because it's so bright. Then maybe I'll turn up the roughness, which the max roughness I can do like that. So here we can see it kind of works. Which this is how the SSGI add-on works, if I'm correct, but I'm not sure. Let me put this back down because we don't need to try, you know, weird experimental stuff. Let's set the lightning colors. I want to try just the, you know, the standard lightning color to see how that feels. I mean, it's not bad. I just need to go and fix up a few of the bugs. Like, I think the lightning is just a hair too detailed. Well, let's turn the detail up, but the roughness, it's too rough. Like, if you pause it there, it seems alright. Let me reduce this by even more. I should taper the emission by the radius just so that we don't get, like, the weird anti-aliasing problems. And, like, red lightning. Or yellow lightning. That's pretty cool. Like, we're getting there. We're getting there. We are getting a little bit of that kind of crawling motion, but I think in this case it helps the lightning effect. Helps sell it. So here, let's try out different things. So here, set the velocity to be higher. Well, we're starting to see it work, I guess. So there we can see that it jumps too far. Way too far. So we need that velocity going. Let's turn that up and then turn this to like 0.05. We could just use a mix, then a normalize, and then have a definite speed, which I'll try that. Let's just try everything in the box and see what sticks. So here I'll just use a mix node. And I think I'll need to, yeah, let's normalize both of these. Just so that the direction will change, but not the intensity. So we'll do that, and then I'll also normalize the output just to make sure nothing gets lost. Then set a definitive speed. So here I cannot get faster or slower. It'll just decide, oh, do I want to continue in the same direction? And actually that looks pretty darn cool if you ask me. Look at that. Like that as an element. Ooh, that'd be cool. Or it could be as spontaneous as it wants. But like that, I think that's pretty cool. And the random, I think that's fine. Like I think they're being a bit too bunched up. Maybe I can have a random speed that I decide on. So I'll do like 0.05 to 0.15. Just so that not quite as the same. Because here it looks pretty much the same, which I'm... Yeah, why is it so similar right there? It also would be cool if I could make the lightning split over time, which I could do. I'll give that a go. That may be disastrous, but why not? Let's give it a go. Let's do duplicate elements. Now I need to save this before I do this, so let me do that. I can say that this is in a good spot now. 3-point sim lightning. Let's see, lightning moving, just to differentiate it between the other lightning effects I've done. Lightning moving. There we go. So I'll duplicate this point, but only a very, very little chance. And only when the age is set to a certain value, because I do not want this duplicating. Because if we do that... Excuse me? Oh, okay. So that'll... I forget. If you set it to 1, then it won't duplicate it once. It'll just have it exist once. So I could just use a join geometry node so that it joins it into the fold. But then again, I could just use a switch node and it'll accomplish the same thing. I think I'll just be like, oh, if it's true, then... Oh. Okay, maybe I'll have to do that. I thought that I could input a field into that. So here, I just need to... Why did I put 2 reroutes that? There we go. So here, I'm just going to make sure... Yep, there we go. So we can see here that that happens. Which, is... You know... I mean, that actually looks really freaking cool. But because this is exponential, it has a really hard time deciding, you know what, maybe I should stop. So I'm going to make it so that it has a random chance. Oh, and I need to make this so that this is changing every single frame. That was probably another big contributor. Yep, it was. Fortunately, their age is the same. And I need to randomize their velocity as well, the new one. So I'll do store named attribute. Let's just set a random velocity. Like, I could store one as a duplicate and then randomize it even more, but I think this will be better. So, random value, plug this into the seed value, plug this into here, and I will scale this down significantly. 0.1. Like, since I do have this as... Let's see. It's too laggy, let me reduce it. Like, it's not having the branching pattern that I want. Which is a shame. I don't think it can have the branching pattern because curves and all that jazz, but it's a little unfortunate. Let's make this extremely little. Maybe I'll not normalize the input velocity. So that I'm hoping we can see this. I mean, if I don't need to use duplicates to make it look good, I will be thrilled. Yeah, I don't think we need duplicates. That's just a huge liability where it's like, oh, yeah, it may explode, but maybe it won't. I don't like how it's all choosing, well, kind of the shortest path. It's all flowing in the same direction like a river. I don't want that, which is why I implemented this, so I thought that would randomize it a lot more. But for some... Oh, I know why. It's because of the... Yeah, no, it's not that. It's because in the trail thing, the noise is set by the position. So if they're in a similar, but not really the same position... Yeah, let's see the particles. Where are the particles going? No, the particles are going in similar places every single time. they're going in very similar places every single time. That is a little less than ideal. It's interesting seeing the lining kind of tickle that part of the back. But I do need to add in the random for the noise trail part. So instead of... Well, let's freeze this so that we can see all that part, all that happening. So that really does bring everything out. The good and the bad of this. So, let's keep playing around with this until it works well enough. So here, we keep mixing this more. That gives a better, yeah, okay. No, that's good enough. Set this to 0.4 again. Like, we can see this kind of descending, which I'm not a fan of, so let's make it ascending. Let's put this into a frame. There we go. And I like having these separated because it is two separate simulations. One for the trails, one for the main. Because that just helps everything else out. So here we can see that part. I'm still not the biggest fan of that. But I think it's fine. Let me turn up the roughness again. Like, that just doesn't look right. 0.6 is like just on the verge of it being right. So I think the 0.55 is the way to go. And I don't think we need 300. Let's set that to 200 and see if there's any big difference. Actually, 0.6 I think is correct when we have a lower point count. Because when you have a lower point count, it kind of smoothens it out a bit more. Let's see. Yeah, this is in a good position. Like, we can see the general, like, everything flowing. We got rid of the, like, bug feeling, which I'm very glad about. Like, look at that. That's pretty good. That's pretty good. Now, I do think there's a way to make it so that you don't even need simulations for this. Like, this still has the problem of, oh, if you were to move the mesh. Like, let me showcase this. It actually looks pretty cool. But it won't follow along perfectly. Which is a problem. Like, it'll follow along, but since the trail is still there... I could make it so that the trail has to stick. By just... where are you? No, I need to go into the particles. So that part is that. Let me put this into a frame. Then let me also make sure the speed is exposed. So that right there, that right there. I'll need to make it so that's always pinned. But it would be nice if it would follow the mesh one-to-one. But that is something that I don't entirely know how to do. So I'll just need to copy this. And of course, it decides not to copy and paste. So I'll just put it right here. Make sure so that it has to stick. And I'll put that before here. So I'll use the proximity node. And plug this into there. And now we should see. I do expect this to give us some errors. Yeah. Let's leave it out. It's less expensive that way. And if your mesh does move, you'll get a nice little lightning trail. That kind of is accurate, I would think. Because... I guess, well, actually, that's kind of like the Flash's lightning. A little bit. But it does also look like the light, well, the noise is too frequent. here, so maybe I'll change down the frequency to like 4. How does that look? I think the roughness is still too high. Let me reduce that. That is not feeling chaotic enough. That felt like proper chaos. Let's move the empty to more around the chest area because I want to see what happens. Oh, someone, sorry, I forgot who commented it. Here, let me undo this. But someone recommended random lightning bolt thickness. Let's see, who was it? Sorry, I cannot re-find your comment. But whoever suggested the random thickness per lightning bolt, thank you very much. I will try that. It was Aditya Chandran. Sorry if I mispronounced your name. I do that very frequently. But thank you very much. Choose a map range. I'm in the wrong section right here. Oh boy. Let's use the multiply. I need to save this again just in case a random crash happens. I'm out of date by like probably a week with this, so there's probably quite a few bugs that still persist. So here, let's see how the random lightning bolt thickness works. I think that does help. Like, you can see the smaller bolts and then the really powerful ones. So let me use a power node to change the kind of... well, so that we have many little ones, but then some major ones. It's hard also to see, like, how this properly looks, because for the bloom, we need all the samples to go through. Let me also set this to be like that. Okay, what if we just had this at 1? I think it being... okay, let's take a look. It going down towards the end, I think, is a good idea. Which is why I had it like... wait. Oh, no, that's passing straight through the body. Ah. What about me? Oh, you recommended having a random thickness per lightning bolt, which I am currently implementing, so thank you for that. 2? Let's see. I mean, it looks really good as just an element, which I think some folks will be very happy to see that. Like, since we're now getting to the point where we can simulate stuff with geometry nodes, it's like, oh, wait a second, maybe we can make some proper elements with this. Like, I do want to try to make, like, explosion effects and stuff like that, because then it might, you know, lead to super cool results. And with this version, it's actually pretty cheap in terms of everything else. Like, the most expensive part of this, which in theory I could offload. Yeah, no, I could offload this. Is the normal calculation because it's updating live for every single particle. But I could just make it. I could just put that inside the other simulation. Here, let me try it. Putting it back into this one. Just to see that if it works the same, then this will make this sim a lot cheaper. And of course I copied the realize instances. which is complete. Oh no, I didn't. Wow. Let's see, how does this feel now? Do the normals. Here, let's debug just the normal part. And of course I can't do... Oh, we can see the trails going through there. That's cool. Okay, let's do this, but just disable the noise for here. Then turn up the normal. Which that can lead to many cool effects as well. That's cool. Having it be more gradual but more potent. That makes it feel a lot more natural, so I'll stick with that. What was going on with that, though? 0.5. I could maybe have a random height for all of these, but I did have that based on the length. So maybe instead of that, it will just be random. Actually, having these random nodes synced up, that means that the thickness will also be... Uh-oh. Did I ruin it? Oh, what was the previous value for here so that I can make it correct? Uh-oh, I might have ruined it. Rewind time. Okay, so it was 0.1, and then that was 125 essentially. So here we go, there's that, and then where's that? Let me take a look at the output. Is that the correct version? It looks close, but maybe not quite. That feels too weird. Even though that looks really cool. Wow. I don't think the normal is correct, though. Let's switch it up. So that versus that, that versus that. So one is a little better than the other. Oh, and that's the noise. Okay. Well, let's take out the noise again. I want to see the difference between the particle stored normal. So there's that, which looks actually super accurate. So let's take a look at a freeze frame between that version and this version. They're similar, but that one is more accurate, so I'll go with that. It's only a few... Yeah, it'll be the same calculation time, just one has edges and one does not. So maybe a little bit more, but it'll be fine. Let me just smoothen that out by a bit. Make sure that is there to compensate. So that's like 0.3, I believe. I need to improve the noisiness of this effect. There we go, we're back in business. Very nice. I should probably place this like this so that's less confusing. We're past the point of making the effect. We're just customizing it. I will need to make it smaller because it's you know. Ah, okay. So since I have the random thickness, the same value that controls the thickness is controlling this, but if I use, say, a white noise, I may be able to randomize that value. Actually, no, Whoa, what is going on here? Oh, I need to snap this by a very, very little amount. Just need to make sure that the thickness does not correlate to the color. This should do it. Yeah, I'm not sure I'm liking the rainbow look. Let me try different color schemes. Like, that's the Infinity Gauntlet one, but am I sure I want that? Could we do something a little bit cooler than that? Here's the purple lining. Pretty cool. And let me turn the roughness down on this so that we get, you know, just a little bit of bounce sliding happening. Lining is hovering just a bit higher. It's a fairly good distance. I will try the length again. I keep going back and forth, which I apologize, folks, but it's kind of necessary for this. Geometry node editor. It is interesting how when you take one part out, it doesn't ruin the effect, but it does change the vibe drastically. Like here, it's just way too fast. So having a little bit of that happening still feels like lightning. This still feels a bit... There we go. That's better. When you have the saturation up just a bit too high, the bloom doesn't work accordingly. Ooh, that's pretty cool. Let's see, zero normal happening, which is leading to that. Then lots of normal happening, but nothing else. Interesting. So I think the noise may be affecting it too much, or like the wrong kind of noise. Like, that's still cool. I do like that. It looks like it's sliding into place, which is better than the bugs that we had before. But, yeah, let's try a different version of this noise. So more like that, but just so that it'll follow its original path better. So we get more of the roughness while keeping the overall path. I only scaled it up by 1. Oh boy. Yeah, let's scale it up quite a bit more. Change the detail down. So here we can see... Oh, wow. Interesting. Interesting. And it doesn't look quite as good in the center right here. Let's change this to a smaller sphere. We're past 1 hour. Oh, I was like, are we close to an hour? But apparently we were way past that. Here, let's try the face. So we can still see the kind of travel down, which I'm not a fan of. So maybe I need to limit the life of the trail by even more. So here it is at 5. So we can see... Let's look at this. I'll try different things. So... Actually, wait. No, I affected the trail. Let's set the trail to 8. But the particles, I want to change a few things. So let's set their age to 10. No, that does not affect that, so let's move that back to 15. I also want to try... So that's the new velocity. That's the old one. I'll delete that, because I could just get back if I need it. Let's get the age value and let's make it so that the speed is affected by the age. So map range 15. So go from 0.1 meter per frame to 0. So here we can see that happens. So we'll slow down. Maybe I do need to make it so that the normal height is based off of the kind of speed of it. Which from the sim particles, I could make that... Oh wait, I could be smart about this. Here, let me move this out of the way, just so that doesn't take up that much stuff. So if I get the velocity length, then I don't need to rely on the overall scale of the parts. Let's multiply this. Okay, it's too low. So I just need to make sure. Maybe I need to make it so that I only affect the normal, not the noise. Maybe I should look up how other Houdini... I say other as if I'm a Houdini person. Well, if I see... I should probably look up how Houdini people make lightning. And then I can, you know, base my effect better. On a better foundation. So here, if I just do that, it's just boom. Let's move you back to the hands, because that looked really cool. But what if they did come from just one singular point? Because the particles could come from anywhere. Let's set that to 0 so that they all come from the exact same part. They all get random velocity, so that's good. Let's also slow down the noise evolution. Ooh, that's pretty cool. Random thickness, I'll have to revise that. Maybe the fancy fall off for that was not a good idea. Oh yeah, that feels better already. So let's go -2 on the animation speed for the noise. Maybe a bit more. And then let me go back into the sim particles, chop out the speed by age, just so that the, you know, all that just keeps going as fast as it can. I think some of them... Let's just do something wild and set this to 50. So here we can see that happening. So 1 just leads to that, go figure. 5 leads to that happening. It's funny, none of them go up to the front. Interesting, so that leads to that. So let's set it to 10 again. So at 10, we have this happening. 15, we have that. So let's move the empty back. I'll stop streaming in a quick second because we're almost at 1 hour and 30 minutes, and that is way too late to be working on a lightning effect. This was supposed to be simple. It was supposed to be fast. But turns out, at least the way I'm doing it, it takes a bit more, just because we need the particle simulation, and then the trail simulation, and then, you know, the lightning itself is just a noise texture applied to a curve. But the steps leading up to that were, you know, less than fun. So here we have just that happening. You know, the pretty standard, ooh, look, the curves are going places. And then we turn those into NURBs to smoothen them out by a good amount, which, you know, looks pretty cool. Then we have basically the noise, which leads to all that. Then I set the radius, then I do that. Then I mesh the curves. Let me put this back into here. There we go. So that is the effect essentially. Looks good. We'll need, you know, some improvements again. Let me just plug this back in and see if that looks better. It does. Okay. It's like, oh, that improvement that I spent a while on? Yeah, no, wasn't an improvement. Redo. Let me just... normal. Merge. Trail. Oh yeah, I should really do... oh no, wait, but... wait, does that only work when it's... no. Okay, that still works after. That's actually going to make it cheaper. Nice. So after I merge, I do the sampling, which, yeah, that does make this quite a bit cheaper. I essentially eliminate more than half of the vertices. So there we go, merge trail. Yep. Looking good, looking good. Which shortcut do you use? It's Alt-Shift-Click to go and click and send that to the end result. So there, Alt-Shift-Click. It's very useful. I think that's a Node Wrangler. Is it a Node Wrangler thing, or is it just in default Blender? Like, Node Wrangler, you just go and enable that. It's built into Blender, but it's still technically an add-on. Should I do a wait for the day when it's just in Blender natively? Because it would just be clicking a button and then boom, enabled by default. There we go. That's looking good. I'm happy with that. Thank you all for watching this live stream. I know it got derailed again. That happens all the time. But yeah, that is a big node tree for just not even like the special part of this. It's just the trails. Well, I guess the trails are pretty special. Like that takes up half the node tree. But everything else, that it's larger than it should be. I'll try reducing it by a bit. There's the new stuff right there, which let me go and yeah, let's separate a bit of this because this is too much. There is a thing as compacting this by too much. So there we go. Let's put that into there and that into there. There we go. More room to breathe. Alright, thank you all for watching, and I will see you next time.